Oh, we are live. Now, second or third episode of the Real Science. And it is Real Science. We're joined by Jeremy Reese, alien scientist, YouTube science extravagant, Andreas Xirtus, co-streaming partner, Mike from Faraday Research, and all of his work on over Unity projects, and Gerald with the hover coil and the fun with alternator builds.
Hey, everybody.
What's up?
So tonight we're kind of going to go over the idea of free energy, the projects that Faraday Research and Gerald have been working on, essentially the crystal builds. Oh, and Jeremy has...
Solo that real quick. What is that? Let's get a little closer to how many coils.
Well, we're doing some experiments with our own little hover coils here.
Nice.
So is that a replication of Gerald's original work, or is that a modification of your own?
It's a replication. We got two of them here. I don't know if I'm going to bring my camera. I don't know if I'm going to.
Oh, are you with Mark at the lab, or whereabouts are you?
Yeah, we're down here in the at the lab. So
back at the Falcon Research Lab.
Oops, I just spilled some water.
Epic place.
Absolutely. Nice. Does Mark want to join in? Fuck it.
I can go Mark. Ask him, but I'd have to leave you guys for a second.
No worries.
Yeah, just after you're done showing us all this stuff, we can totally invite him. He's welcome.
Yeah, I'll email him the link right now.
Let me go ask him. He's right in the other room.
Okay. For sure, that's wicked.
I'm going to ask Charlie. There's actually a bunch of guys here. We'll have some.
Oh, sweet.
Very nice.
We're going to grab something here. I'll be right back.
Yeah. Okay. So, well, you ask, and Gerald goes and grabs that. Mike, maybe you want to tell us a little bit about what you've been working on.
Yeah, exactly. Please. So, I'll put on a silent clip of a demonstration of one of your Don Smith experiments first, and then your Adams motor if you want to talk over them, sort of thing.
It's like a real science talk show. We have a clip. I've heard we have a clip. Play the clip.
Yeah, so basically this project here is just kind of a demonstration of using disruptive discharge to power an incandescent light bulb by using 2 spark gaps. And I also have, you can notice in the top right-hand corner, I've got a vintage World War II production model of vacuum spark gap that was used in radar systems on the battleships, that one there. Nice. So I managed to get a hold of 6 of them. They've never been opened. They have the original seal. They were released in March of 1945, and wow. I got 6 of them. And they were used as part of the power system for the radar system on the battleships post-World War II. So I got those. I got a larger model of them. They were made later. They were like early 50s. So yeah, just kind of showing how you use Tesla's spark gap. He always played, well, back in his day, they didn't have transistors or MOSFETs or anything like that. So I just want to demonstrate how well that works.
You guys there?
And creating enough voltage and amperage to power a 25-watt incandescent light bulb. So,
nice.
That, yeah.
Wow.
And it works very well. But a device like that, because it's disruptive discharge caps, you have to Faraday cage it. It does have quite a bit of emissions coming off it. So,
Wow.
So I was getting quite a bit of light off it and also quite a bit of heat. So I was putting in about 11 watts. I was putting in 11 watts and I was powering 25 watts.
Nice. So where were in those radar pieces that you got?
Where did I get them?
What are they? What are they? But also where did you get them to?
Yeah, they're a vacuum tube spark gap. So they have,
Yeah,
I
there are
believe,
two tubes right there. You can see the plasma arcs in.
Very
right?
nice.
yeah.
And
Wow.
so this is a Don Smith generator build. There's many YouTubers that have replicated this design and then experimented and added their own different alterations and whatnot to it, like Mike's been doing. And you found that a big part of it, Mike. There's a correlation between the spark gaps themselves and the amount of energy that's going in and out of this
Okay.
systems.
Yeah, it's because if you look at all the Tesla stuff he used, disruptive discharge, it has to do with the spark gap. It's either tapping into what you would call the 0 point or vacuum flux, and it's allowing that extra power to come into the system. I don't think all the gains are done within coils. I think the coils assist in creating that initial shock wave that basically pushes the ether wave out, and when it discharges, it collapses so fast that the ether has to fill in that space again, and that's where you're getting the gains, is by the ether collapsing in on itself.
Okay, well, really quickly, because we're now in Jeremy at the Falcon Research Lab. Let's look at the lab for a second, and we'll come back to the Adams motor generators.
Hey guys, we are live from the lab here.
Solo that, Bernie.
We got Charlie C here.
Hey, Charlie, what's up? Good to see you again.
Great. Yeah. Doing well.
Hey, Charlie.
Hello, Charlie.
Just
Nice.
cutting some stuff.
Oh, that's my old baby. I used to work on that machine.
Oh, nice.
What's up,
I
guys?
missed that.
Hey, Mark, good to see you.
Yeah, we're cutting the disc for Jared's. Jared's gratifier. He wanted an 8-inch disc with 6 holes, and after that, we're going to be cutting the 1/4-inch panel for Easy Alzaphon. It's going to be really cool.
Epic. So what are these panels for? Tell us a bit about what this is intentional. What's the intention of this?
These are for a couple different experiments we're trying to run, and we got the capacitor banks from George Hathaway when he passed away. These I don't know where these came from. 76, late 70s. These are some serious capacitor banks. They probably got some interesting materials. Then we got this thing we're trying to do for the we're gonna do a replication of the Polygon gravity impulse generator experiment. So we're gonna mount these superconductors. Cool.
Whoa!
Going in. Hold on a second.
Air compressor bomb.
You never know what's going to happen in a live stream.
Indeed. Hopefully, no nudity. Freaking porn bots. Luckily, haven't seen them recently.
Jeremy, so you know you're muted still, but maybe you're intentionally so because it's so loud. And if that's the case, we understand.
Well, that's also the sign of a true workshop at work is, the air compressor's going and the motor's running, the wheels spinning. Jeremy,
Your
Jeremy,
CNC machine takes a lot of air. That I worked on that Haas when I worked at the aerospace company, and
You're muted. You're muted, Jeremy. You're muted.
Jeremy, we can't hear you.
Unmute yourself. There you go. You were muted.
There's the compressor's going right now. Give it a second for it to shut off. It's just loud as shit.
No worries.
yeah, the old Haas take a lot of air, right? Runs all the tool changing and all that stuff, so demands a lot of air to run that.
Right, because Mike, you've been working in that industry for a long time, like in aeronautics and
that
and
a
all
lot of
that.
robotics stuff like that. Yeah.
Nice.
And so what's the plan with this? He was putting that copper wire or the tube around this long acrylic or glass tube. Do you guys know what that's for?
Well, the tube is probably going to create a dielectric for what the field is going to happen on the
Sorry, I
inside.
will be right back.
That's what I could see, because acrylic is probably the best thing you could use as a dielectric. So the only way you make electricity is you have to have two components, dielectricity and magnetism. If you don't have those two things, you don't have electricity. You can't have one without the other. And that's it. And that's comes directly from Dollard's work. So dielectricity and magnetism. You got to have those two components to make electricity. Well, we know it's electricity.
So is it kind of the intention of putting it inside of a field?
Well, you have to manifest it. So it's not generated. The energy is already there. You have to manifest it. So basically, like your regular electrical generators of today, the best way to describe it is a magnet folded inside out.
And capturing itself or capturing the energy?
Right, you're manifesting it. It's basically a magnet inside out.
I could see how you could look at it that way.
Kind of that's the best metaphorical way of,
Yeah.
Gerald, elaborate. What are your thoughts on that, the inside out magnet?
Well, I understand what he means by building up on a field. Because that's kind of how my system works. I guess that's how most systems work. But in order for things to react in different ways, the field needs to be built up to a point where there's a lot more potential.
You have to basically get it through that dielectric median, and you have to create the field. Without the field, you can't tap off it. There has to be a field present around the device itself. And as long as you got a good dielectric in between that, you'll be able to transfer the electrostatic magnetodielectric, which Dollar talks about, and transfer that into a third dimensional reality voltage, what we know as voltage.
I'm working on a bit of a larger field right now, and I've learned to separate my fields in different ways. So I'll give you a little bit of a visual demonstration.
See, when I see that, when I take a look at that, I see a magnet. Okay, the center.
Yep. So as this spins, it's pulse rate.
Yep.
This is actually what goes in the middle.
Right.
And it's my pickup coil.
Yeah,
what it is it's a stator from a
washing machine
Fisher washer.
Yeah.
And I've had some pretty decent results from it. Nothing I'd write home about, but at the same time, the fields do have to be built up to the point where I'm getting saturation or close there too, and then I'm getting a lot of voltage.
Have you ever tried introducing a spark gap into that circuit to try to build that field?
I have actually, and I just built, excuse me, or in the process of finishing building this spark gap right here.
There you go.
So,
wow.
Are you going to put any kind of noble gas inside, or?
No, at the moment, no, but the intention is to later. Yeah. I got a vacuum pump, and I'm going to do quite a few different variations of that test, actually.
Even just ejecting the air out of the tube, you're going to see some great results, irregardless of putting a noble gas inside. You can't do that later if you want, but just removing the, get it down to 1 or 2 atmospheres, you're going to see some huge gains. Yeah, you'll see some huge gains.
Yeah, that's the intention anyway. That's the next set of experiments that are coming. So, yeah, one step at a time, though.
And you guys were talking about, you were explaining dielectricity. Could you explain dielectricity a little bit more for people? Maybe like introduce, it's kind of a new concept for some people.
You want to take that one, Mike?
Sure. It sounds easy to explain, but it really isn't. It's just basically the median in which the potential from the ether or the space around us has to penetrate through that median in order to get to an inductor. Whether it's a magnetic field with the inductor, it's like a barrier that it has to pass through.
Basically, the space that needs to be filled in order for your inductor to actually work in between.
Exactly. Yeah. But there's a lot more science to it. I really recommend, if people want to get into this kind of thing, you have to study the forefathers: J.J. Thomson, Heaviside, Tesla, and Steinmetz. Steinmetz is a big one there. You're really going to study his work, because they were the real electrical engineers.
They were the forefathers of it. Yeah.
Yeah. So basically, everything that Tesla ever made, Steinmetz perfected it, and did the math with it.
Yeah, Steinmetz definitely. He actually continued a lot on the math more than he did the experiments, from my understanding.
He actually put out more patents than Tesla did.
Oh, really?
Yes, he did. Yeah.
Interesting. You learn something new every day.
Yeah.
And so what kind of patents was Steinmetz putting out, and what kind of
Well, basically the mathematics that goes into the geometry of building the AC motor without it blowing up. Where Tesla was more of the concept guy, putting it together to make it work, but Steinmetz made it reliable and efficiency, and so just
Tesla was an experimenter.
Yeah, he was, but Tesla too knew his math. He was an electrical engineer by trade, but Steinmetz just kind of took it a step further. Yeah,
nice. I don't know a lot about Steinmetz. I've read a bit, but I'll be honest, I'm no expert by far. So
yeah, he was definitely an interesting person to study on. Study, like you said, the forefathers of electricity, and to really get a grasp of what electricity really is, and how it works, and how you manifest it, and how you manipulate it, how you understand the fields of magnetism and their correlation together in space.
Wasn't Steinmetz?
He was the midget. He was the one that.
Was he directly involved with building the television?
No, that was what's his name? Farnsworth.
That's right, Farnsworth.
Yeah, Farnsworth. Yeah, he was a little bit later. Steinmetz died, I believe it was 1929 when he died. So pretty much after 1929, electrical engineering, the real electrical engineering, pretty much ceased. And then the Einsteiners took over, and electricity to the Einsteiners is like public enemy number one. So they were the ones that really created all these laws and relativity, and really put a spin on it and suppressed the technology, demonized it.
They say you can't get more out than in, right? So
yeah. So you know what? I think personally the cat's out of the bag, and they said, even Tesla himself said, the bankers and all the money mongers, this might be their century, but the next one will be mine.
Yep.
So I think we're getting to that point.
Right.
This tech's definitely going to get out there. Everybody's going to get their hands on.
Here it is happening.
Because there's millions of people worldwide, like myself, working in their garage or wherever in their basement, and they're building stuff and they're learning. So this information's getting out there. What little bit of information or little breakthroughs I can make, if somebody out there can take that and take it a step further and go with it and make something great of it, that's it. It's all part of the manifestation of advancement into the area that's always been demonized as pseudoscience, or
I agree.
Right.
So yeah,
Jeremy, if you can hear me there, what are you working on? Can you unmute yourself? Show us that. Can you hear us?
He's working on a Starship coil. That's what he's working on.
Right. I want that skateboard. I need the Mattel hoverboard. If you can't hear us, can you hear us? Unmute yourself.
It's a nice coil.
Can you hear me?
Yeah, there he is.
It's a 24-point star challenge hover coil.
Yep.
And so just now, what are you guys putting on it right now?
5-filer.
AC. Yep, 5-filer. AC from a Variac.
How many wraps do you have on that? Do you know? Maybe I shouldn't ask that question on live. Never mind.
They're discussing whether it's part of their NDA.
10,
Yeah.
6.
It's all good.
Or-
Don't.
How about we put wagers on it? Yeah.
Right? Yeah.
Glued. Yeah, this one's
If you can figure out what amount of coils it ends up needing to be,
Well,
then we'll send you a free pair of Xirtus rainbow glasses. Just hit us up in the Discord.
and I would say good luck on that, because looking at a coil in the geometrical form, it is almost impossible to guess the lines that go into this. The parallel line inductors in this is insane, the amount that there is.
Well,
The one that he's got on his desk there is not just a simple solenoid wrap. I'm betting there's got to be at least 75 to 100 on each side.
See, back in the day, just kind of a little tidbit for everybody. Back in the day, Tesla never counted windings; he counted mass.
Yeah.
So
Makes
when
more
he
sense.
wanted to get two resonant coils, he always measured the mass of each coil, and that's how he did his math.
That guy Ilya.
Way more logical. And the electrical machine on the table, explain what that is and what's going on there.
Oh, you want to help me out with the?
That's a very
Yeah, this is a variable AC. So see some of the AC voltage. Just want to check it, make sure we didn't blow a fuse, because these coils are basically just shorts, So we got to be careful. We had blown a breaker earlier testing it. So now it's only going up to like 2 volts AC. So I think
turning on. Yeah.
we just gotta maybe get a new variac. It's not going high enough. Yeah, like he's turning it up to 10 volts and it's only reading 2 volt AC.
wow.
It could be stuck or something. Why wouldn't it be showing anything? Is it stuck there?
Yeah, it's stuck at 2.
I didn't
What if he
put it
takes it
up
all the
very
way up?
high. I only put it up like a couple.
Yeah.
We got a much more
Clicks.
powerful one.
Yeah, you guys set it up like much higher. Really.
Well, okay. While you guys fix that, Mike, maybe you can tell us a little bit more about the backstory of what brought you in to Xirtus a little bit before. We can also get back and go deeper into that. But tell us a little bit what got you to do Mike Faraday research and everything.
Well, started for me probably around 2005, 2006.
Jeremy.
I've seen these guys building these HHO generators for the cars. So I just had to build one of those units. I installed it on a 2001
This is a
Pontiac
20
Grand
amp
Prix.
one.
Hey,
And-
Bernie, mute the other chain on the back while he's telling the story.
And so I built a unit and increased the fuel mileage in my Pontiac by about 25%, I would say, respectively.
Nice.
And so I know a lot more now about that generator, how to actually perfect it. And it gets into the Kenneth Shoulders plasmoids. And so I'm working on
What are the Kenneth Shoulders plasmoids? Elaborate a bit on that. What that means.
Basically, oh God, there's a rabbit hole right there. If you really want to get the real scoop on Kenneth Shoulders, talk to Hutchison.
Okay.
Because he worked with Hutchison quite a bit. Basically, he was creating these disruptive discharge sparks coming off a very small inductor, and they were shooting off, and they would hit any type of metal. It didn't matter if it was titanium, aluminum, high carbon steel, whatever. It would vaporize it.
Wow.
And they were actually creating these little entities. They were actually growing. They were moving. He also showed in some of the videos he had that there was like they were alive.
Well, I guess if viruses bacteriophages are, then this can be. That's crazy.
So he actually patented one of his devices, and he got quite a bit of attention with that, even with Hutchison. When Hutchison was doing it too. Yeah, see that last patent picture you showed there, Bernie. Of the
This guy here?
that one there. See how he was discharging, and that's the actual drawing he has on his patent.
Mm-hmm.
So it's like ball lightning. He was like creating these ball lightning, and it turned out that these things actually had some form of like intelligence, that they were actually moving around and like they were alive. It was like he was creating a electrical life form.
Whoa.
It's really strange stuff.
They love to eat
Soon, yeah.
What do they like to eat?
elements, whatever that they're being shot at, actually, and they like to find the most conductive element that there is, and they go to town and they munch.
The
And they
EVOs.
transmute elements at the same time.
Yeah, EVOs.
Yeah, very interesting.
So it's kind of like a biofuel in the sense the way you were using this to assist your car, or what? How are you using it?
No, I was just using basically distilled water with a little bit of sodium carbonate in it as a electrolyte, and charging the 2 plates, one positive, the anode and cathode, and thus creating hydrogen. But I have designs for one that actually eliminates the hydrogen process altogether and just creates the plasmoids.
Nice.
And by using ultrasonic water vaporizers, charging that vapor into the plasmoids, and then injecting that into the intake manifold of the engine.
Wow.
Very nice.
Let's go back to the lab for a second, and we'll come back to the plasmoid car. Jeremy, you're muted. There you go. Can you hear us now?
Thing going now. Nice.
Oh, that's my Variac.
Magnetic ball spinning around in that test tube.
Yeah, really see it spin around. So we try to
Do
color
you guys
it
have
black
a magnetic cylinder with a hole through it, and you can shove a shaft through? You're going to create an inverted motor almost.
This is fascinating. Solid state motor, solid state magnetic motor.
Yep.
Well, basically, that's what Tesla did with his alternating current. He did that with the egg, the rotating egg.
Yep.
That was.
If I'm going to take your dog outside, you're going to go on there and give them an update on while I'm not.
let's mute again until they're ready to do the update.
Yeah. Hot mic moments at the lab.
It's kind of like CNN. It's kind of like Wayne's World. It's
So
got
we
Mark.
just had a-
Mark.
we
What
just had
up,
a
Mark?
Now, if you guys want an update, then listen. So Professor Tom is giving Wayne a lecture on all that stuff. We have backup internet here. That's from Hawthorne, California, and this is coming out of the CNC machine.
Oh, cool.
Very
Grabfire
nice.
show. Very
I'll
nice.
let us see.
Okay, you want to pull it out? Oh, he got liquid nitrogen there, and
Nice.
Peaky really. So Jeremy's gonna take Peaky out for a poop. Oh, here's a leash. Yeah,
Rock in space.
There was a scary incident.
Jeremy, I'm gonna give you a medal. You deserve to be commended for all you do.
I mean, sometimes you just got to
Beautiful
take the
dog.
dog out.
It's a beautiful dog.
out?
The dog's the mascot.
I understand.
Exactly. So
Speaking of
the
dogs,
next thing that's
sorry
going
to
on to
interrupt.
the CNC machine is this block of aluminum here. We're going to make a disc out of it. And this coil, we call it the ARV coil. So we're going to have a rotating disc of aluminum inside this pulsating coil. And it's going to be provided with power from this huge bank of capacitors over here that we got from
Huge.
Yeah,
Nice.
that's 26
Absolutely
joules of
huge.
26 kilojoules of power.
Kilojoules, 26 kilojoules.
That'll
Yes.
26 kill you.
Yeah, seriously.
And we have
That's
an
about
8
right.
kilowatt, an 8 kilowatt power supply, runs on 3-phase up to 45 kV. And we're going to pulse that whole thing, that bad boy, back and forth and port it at the North Star with a scale on it and see what happens.
Wow.
Okay. You're having trouble there. You kind of need like a flathead screwdriver for that. Yeah. Or just figuring out how to pry the gravifier plate out of the CNC machine. Over here in the yellow toolbox. Here. No, use something a little sharper than that. This one might work. Okay. Or there's this one too. You kind of need like a scraper or something like that to get it out. Oh, you got it. Get the lights.
And so, what is this thing that they're pulling up?
Oh, it's a plate for the Gravity Flyer, for Jared's Gravity Flyer, and we're making it for him. The next thing we're going to do is the whatchamacallit, the Easy Alzaphon center aluminum disc. And Charlie.
What's up, Charlie?
Hello. Easy over here. Hold it.
So we're going to have to hold this down to the base of the CNC machine. And to do that, we're using, this is basically like double-sided tape in a paper form. It's
Okay.
called Mighty Grip. It's a really great CNC tool for super thin materials. You can use the
Blue tape.
the blue tape method, but that won't work for stronger cuts, like where there's a lot more material to be removed. And it basically just works like any hot glue. You just got to heat it up real well. Although it does have a pretty high temperature of adhesion. So we're gonna have to use torches to warm it up.
No
Like a
hair
little
dryer.
flame.
Yeah, the hair dryer didn't do a good job last time.
I know Mark wanted to try a hair dryer first.
We
He's a
literally
safe
have a hair
guy.
dryer on the machine.
This is the irony here. Mark is always trying to do the lesser thing. He's like, I'll use the hair dryer if I can. He only ends up using like 26 kilojoules because he has to. You know, he has kids. He's careful. It's just you need 26 kilojoules sometimes.
Maybe you do, maybe you don't. Let's see what happens.
Okay, so now you're applying the material to the cut thing, or did you do that already? And now you're going to. What are you doing now?
Oh, so I'm setting it out, trying to lay it out perfectly square with the machine. Okay. I got to pour that in there. Thanks. There's a mess here.
Yeah, melted.
Oh, no. I'm gonna have to work on this later. We're not using that tool for this setup, anyways. So, okay, now I need to pull the top layer off, and then we get the torches.
You can hear in the background lab technicians being whipped because they're interns. They're not quite fully accepted yet.
Okay, there we go. Where did I put the torches? Okay, there.
This guy right here. Do what you gotta do for science.
That hot plasma and like nano coating metals, it's actually crucial.
Guys, cover your mouths. You don't want to breathe this stuff. It makes you crazy.
That's what you call hot glue.
Right there. Good job, 3M. Melting point of 140 degrees. Whatever it is.
That's our compressor getting ready.
Should we move you?
Butane. You need to already be crazy to do this, Wobbly Boost says. Maybe you're right. I don't know. I feel like the society drives you crazy, and then you just want 20% more mileage to your gas
We gotta
tank.
cool it off, and then we gotta start the program.
All right.
Yeah, so that's what's going on.
Epic, Mark. That's amazing. Thank you for showing us that. Charlie, what's up? So, like, what do you have any comments on what's going on in the lab, Charlie? Any thoughts on what's going on today?
A little bit of everything, and it's good research. So it's good to have everyone in one place to help them kind of get inspired. And tomorrow's APEC will be the 2-year anniversary, so that's why we're getting ready for that.
Very good. How close do you guys think you are, we are, the world is to achieving some sort of a world recognizable step towards free energy or anti-gravity or alternative propulsion, any of these things?
That's hard to say. Can't really dictate innovation. But I hope we still have time before the end of this year, so we'll keep trying. And
There it is.
year, if not this year.
The realist strikes back. I appreciate that. All right. Well, okay, so then let's pull back to. Oh, are you gonna do the thing? Yeah, show us again.
Oh, I put it over there. This is where the code cut it is stored. We got program CNC, and we also got to toggle it off, tell it where to go.
Tell it where to go. Tell it where to go.
So for this, we're going to go to. We're going to call up
Man, see,
20 M6. That means call up tool 20. And tool 20.
it's just so fun, you know.
Nice.
Nice.
Yeah, that machine's my old baby. I love that machine.
And what were you used to
Here's
doing?
the Haas VF2.
Yeah, that's the one I used at the aerospace company.
What kind of stuff were you using it for?
Aerospace parts, we were manufacturing stuff for Bombardier.
Wow.
Yeah.
So for like the side of a plane or a jet or like what kind of things?
Wing parts, fuselage parts,
Nice.
subframe
You're
parts.
cutting like 6061 aluminum a lot.
Yeah, we were using AS 2001 certified aircraft aluminums. So it has to come from a registered AS 2001 certified facility. Everything's all tracked.
This is 6061 aluminum, or the aircraft grade, the most common stuff you find. But we have been looking into 5052 aluminum, and interestingly enough, the combination of metals in 5052 aluminum works well with the Alzafon dynamic nuclear orientation experiment. And 50 and 52, the center number is 51. That's an area 51.
Nice.
I don't know if that's
what is 50, 52, and 51 used for? What else is that common in aircrafts or
mainly aerospace?
51, I think, is most common. I'm not really sure. You can check it out.
Yeah.
Because if I'm always interested in what aerospace is using because I feel like they have a bunch of tricks up their sleeve we're not hearing about, you know?
Yeah, well, they use titanium. Like we used titanium, we used Inconel, which is a very, very tough steel to work with. Yeah, mainly those three.
Do you have any thoughts on the idea that planes are able to fly longer and further without as much fuel as we're told they're using? It's like an internet train of thought.
The engines are getting more efficient as every year, right? They're just getting better and better, but still, you're burning a kerosene-based fuel, which is extremely bad for the environment. If anything, I would say planes create more pollution than the cars do.
Oh yeah, for sure.
Because they're using a kerosene-based fuel.
I just wonder about like how many planes are just able to use ionic lifting and we're not hearing about it. I mean, obviously like Lockheed and stuff.
I personally think the B-2 is using it right now. They just won't admit to it. It's also airframe design. Airframe design alone will save you a lot of fuel. It's just it boils down to the engineering. So
I see Beegs in the chat. What's up, Beegs? Hello. Great researcher. Sorry, Gerald, you were about to say something.
No, it's all good. I was just going to say material sciences keep getting better and better every year as well.
Absolutely.
Very, very much. Like we did some aircraft, what they call them bulkheads that, basically help form the skeleton of the fuselage.
Yep.
So we would get a raw piece in for cutting. It would weigh, about just over a ton. And after it's finished machining, 20 hours later, I can lift it with one hand.
Wow.
So that goes to show how much material actually gets removed from the solid piece when we get it, right?
Yeah, and a plane is essentially a skin. There's really nothing to it.
Yeah. It's the engineering, it's the structural engineering that gives the strength of the plane. So
yeah, the form of it as well. Yeah, the shape.
Yeah. And like you said too, it's the material science. It's just getting better and better and better,
Lighter.
and lighter. Yeah, and that saves you fuel, right?
Yep.
If I was trying to build a UFO, I think I'd not use a flying saucer. If I was working for Lockheed, right? I would if I had to build like a military craft, I would make it look like a normal plane, like a Cessna or a Boeing, or something. Because then people wouldn't care so much, and then every once in a while the plane would just go boom and can just fly straight upwards or something. And people are like, that didn't happen. Just it was a mirage. But
see, I'd do it opposite. I'd build it like the Flight of the Navigator, right in your face. Here I am.
Yeah,
that's what we did. Dude, did we talk about this last on the Flight of the Navigator? Like they really built those crafts. You know that?
They did, really.
Yeah. So because in the commercialization, they tell you that the thing was CGI and all this stuff. It was like the earliest CGI, and they did pay somebody to do some CGI stuff. But there's like I think 16 scenes or something like that are actually CGI, and they're very brief. Most of them are like Back to the Future, where they have a thing that they've mapped, and they have a machine that's taking frames around the thing, and they can move it, and it's an auto track camera that takes frames.
Oh, wow.
Right. But then they also had, so that's a model that's only like, I forget if it was 7 feet or something, or it's 3 feet to 7 feet. But then they built like a 30-foot one in Florida, and then built another 30-foot one in Norway. And then they did a whole bunch, and there you can walk inside the thing with a full-on interior. And the one in Florida, they like lifted up around places so they could film it. But that's got to be one of my favorite conspiracies is the Flight of the Navigator was a cover-up for Disney just building real flying saucers. They're like, yeah, no, it's a movie. Everybody calm down.
It was that like era and time of also like the Honeyboo and all of the Nazi UFOs.
Yeah, Norway and Disney World.
Back then, so many.
Paul Rubin, Pee Wee Herman as a cover-up for AI. I mean, the whole thing, man. I don't know.
Pee Wee Herman.
Honeyboo sounds like something completely different than Hanniboo.
Yeah.
Yeah, there we go. My bad. Maybe like cottonmouth, horrible Canadian pronunciation.
Oh, right, yeah. Blame all of Canada.
Tell you, Honeyboo, I said hi.
So that's interesting, Jeremy. The stuff going on in the lab does look pretty good. That's pretty good stuff.
Yeah, we're doing some interesting projects down here this weekend. I'm glad I came down, and I went and bought that symbol out there. I want to do an experiment of my own with that, with some cymatics and driven resonant frequencies on the symbol.
Nice.
There you go. We're also going to coat it with some proprietary compounds to elicit some desired physical effects. But I won't talk too much more about that.
You gotta be careful with Alchemist. You know what I'm saying?
Yes.
But okay, also
trusted. Everything is punishable by death.
That's true.
Supposedly.
But Gerald,
once you guys
you died, it's don't even worry about it.
Then it's over. Yeah. Well, but maybe. But
I don't
Gerald,
know. I've died once, so
yeah, it's not really over almost ever when they say it's over.
Yeah.
Could just get worse though, so be careful.
I have a suggestion for that coil. Instead of using AC, I would use a pulse DC and put it through a transducer to get the ultrasonic frequency up to about 300 kilohertz and see what the how it resonates. You might be able to get some lifting.
I could absolutely throw a square wave on there with a. Hey, do you got a function generator? Hey, Charlie, is there any way we could throw a square wave on this coil? And see
if you have a transducer, hook it up in parallel with that coil and get that transducer vibrating, and you might get some interesting effects.
You're correct. Use a square wave pulse, and then on the secondary, use a full wave bridge rectifier with a polypropylene, maybe 1.2 and higher kilovolt capacitor, and just see what happens.
Okay. You want to come to the lab and test it up? It sounds like you know what you're doing.
He's in Canada. Do you have any idea? Like, there's a wall now, isn't there?
No, we have people here from Canada.
No, shh.
Don't insult the lab with Canada. Come on.
They use the
No.
metric system in Cyrillic.
not
You got to be
that.
really careful about the Canadians.
We'll
you know?
send our one fishing boat at you. Eh?
Yeah.
Gotta be careful. But
And our squadron of Canada geese.
All right.
That's it.
I'm
They're
afraid.
already attacking. They're flying south right now. They're gonna be dropping them bombs on you.
Geese are scary.
Canadian
town.
bird
This tastes
bird
good.
is
Little
from
geese
a
are
Canada goose.
Geese aren't a joke. But I was gonna ask Gerald what you've been working on this week too, because we heard a little bit of what Mike was doing, a little bit of Jeremy. What about the stuff since last time we spoke?
Yeah, and maybe can you explain, Gerald, a little bit of your triple alternator build design? If that's
Actually,
right.
I've been taking my alternator and putting it in a nice stainless steel box and wiring it all up so that it can run the house on a regular at this point. So I'm just about to do videos, and I can do a big demonstration, maybe the next video that's coming up. I still have a couple of more wires that I have to connect. So like I have to hook up my MPPT controller from my solar panel that comes from my grow room that goes to the one charge battery. You'll see the setup. I'll give it a full schematic and a once over. Everybody will get to see the demonstration. Yeah.
Epic. That's cool. And yeah, so that's awesome because we saw a little bit of it before. Is it nearby where you can show the thing that
I don't
people
know.
see what you've been working on?
You know what? Maybe if I hook up my secondary camera here and
If it's all far and hard, I don't mean to make it super difficult on you.
yeah, well, you know what? It shouldn't be too difficult.
All right, cool.
But as far as coils goes, I'm in the process of building a brand new one, and I'm in the process of complete template to be sent out to people to build the exact replica of my big coil, and it will be given to various people. Actually, the template itself is done. I have to get the steel punched, and then I could consider handing them out to individuals. Like the lab should get at least one, if not two. One go to Charlie, you know, whoever wants to replicate my work, so to speak. So we're at that stage now where the template will be given out and the schematics and then all the parameters that I used for all my tests and the things that I've achieved, that'll go out as well. So everybody can replicate it and show me I'm full of crap or show me I'm correct, one or the other. It'll be a fun trip either way.
There you go.
So let's see if I can do this. I'm not sure if I can switch cameras easily.
And here's the video from your channel, your new channel.
And it'll say extra camera as one of the options.
If I can just level it out here. Okay, so there's the 3 alternator generator there. I don't know if you guys can see that.
BurnEye, pull it up.
Oh, I don't know if it's showing my camera. Can you see that?
Yeah, we can.
So that's the alternator.
Oh yeah,
I
in
can't
the
do
box there, the
demonstration.
double.
There's 2 separate power inverters in there. One's 3,000 watts, one's 1,200 watts. And then I don't know if I can show, it's kind of dark, but the 2 alternators there, and then there's one in the back. This one on the right charges a 48 volt battery bank. This one on the left charges a battery bank. I'm not sure if I could show you. Yeah, it's kind of a mess. I have 580 amp hours of battery bank sitting behind this thing to run my house. So it's a nice setup. When I do the demonstration, it'll be a little bit.
And how much power can you like? So let's say you're running a house, an American house. How long can it run? What's the power you're getting?
Well, that's kind of a loaded question, but basically, I can produce 300 to 330 amps on a consistent regular basis of DC, which equals about 30 amps AC. So I can run a stove. I could run a fridge and all my lights. I can run a couple of heaters in my lights. It won't run the full house as of yet. I can only run about 30%. But with a larger battery bank, of course, anyone that deals with solar understands that the bigger the battery bank, the more you can run. And the alternators will just turn on as the batteries get low, charge them back up, keep the system running. That's all it's going to do.
And then you could also have like separate systems, you know, like solar panels just for your laptops or something. A lot of things can run off DC directly. So,
well, it's all part of a bigger system. I have a solar panel in my indoor grow room. I built a grow room for food, and it's a 400-watt solar panel. I don't get out my full wattage, but I get out about 300, 310, and that tops up my start battery. And then as the system starts, of course, the indicator tells it what voltage it's at and whether or not the alternator should kick on full or not. And the way that the system's set up, if my math is correct, just with the batteries I have now, I should be able to run at least 1/3, if not half of my house, and the alternator system should turn on maybe once an hour for about 10 minutes all day long. So consistently, it'll turn on for 10 minutes, shut off once an hour, keep the batteries charged as I'm running. But that's coming in the next week. I should be doing all those tests.
Dang, it's going to be epic.
Yeah.
Off grid, but on your own. There it is.
That's the goal. And the grow room itself, I have solar hot water panels in there. So they help heat my hot water tank. And the excess heat that comes out of the grow room goes directly into the intake of my furnace. So it helps heat my house. So as I run 1,400 watts in my room, you got to buy food anyway, right? So you're going to grow it. Why not? So I'm growing indoors consistently 24/7, and I'm supplementing the house. So it's more of a formula that works rather than just one system or two.
Right.
Yeah.
Yeah, you have to have a bunch of little things. There's all these different things that you can harness the energy, manifest.
Energy harvesting, yeah, that's the way to go.
Yeah, manifest, as Mike had said earlier. Actually, I'm curious also, Mike, some of the things. So you talk about plasmoids, a bit about Steinmetz. Maybe a bit, like, give us a little bit more of a vision behind, this free energy system and how we got here so far, and like what you've been working on connected to that.
Yeah. Oh God, where do I start?
I like loaded questions. I don't know if you noticed.
Yeah, it really kind of took off since I introduced the piezo transducers to the circuit. Jim Murray, Paul Babcock, those guys have been working on advanced switching techniques to compensate for the capacitive inductance in the coil. So I found a new method of releasing that power that's been trapped inside the coil. By using the transducer, it releases this energy. And right now, I've done a few tests using the scope. It's showing that I'm getting about 18 times more power out than what I'm putting in. So I'm putting about 0.98 watts, and I'm getting about 20 to 25 watts out.
So you're saying, so I was talking about accumulating energy, but you keep saying manifesting, and you talked about the mass. So is this like an antenna, like a mass antenna, or what? How's this accumulating and manifesting energy so much more?
Right. So if you study, say, Joseph Newman, he had a motor that weighed 7,000 pounds.
Yeah.
So
it was an inverted motor.
Yeah. Basically, inverted motor, 7,000 pounds. All right. So you would think that would need a lot of amperage to run it. So the theory is the more mass you have and you spike it with high voltage. So he was sending in about 460 volts DC at 50 milliamps. He was able to move a 7,000 pound mass.
Yeah.
which is totally incredible when you think about it. So the motor doesn't need amperage to run. So if you look at my motor, I'll put in 24 volts, but it's only consuming 40 milliamps. So yeah, and I'm getting 18 times more power out, reactive power out. That's the motor there.
Yeah.
So he was running a giant pump with that. It was pumping like 200 liters a minute. So when you have a big mass like that spinning, you got inertia, you got mechanical power. So you can power a small generator with it, or a water pump, and it's only consuming voltage. It's not consuming current. And that's why his machine is over unity. See, as soon as you introduce current into the system, that's where the inefficiencies start. So if you can design a motor that requires a very, very little amount of current to run the machine and produce that back EMF and get it out, you're going to get way over unity. So the idea is you have to build a super, super efficient motor. And if you can achieve that, which I've done, now all you have to do is tap off the vacuum collapsing energy of it. There's a smaller version of Newman's motor. Now the secret to Newman's motor is mass. So to make that motor have the efficiencies and the over unity that his system did, you have to have minimum 260 pounds of copper.
Yeah.
See how big his motors were?
Yeah.
So the more mass you have,
Whoa.
the more over unity that you're going to create.
He used centrifugal force. He used the mass. He used magnetics.
Mm-hmm.
It was an interesting machine by far. Mobile, Alabama is where he built that. Yep.
Interesting.
So like his story was he fought the patent office, fought them for years, and in the end he still lost because it's all rigged. It's all rigged. The oil boys didn't like him.
What did they say? Like it didn't work, or they didn't? Why did they not let him have a patent? What's the?
Well, he had it tested by several labs, proving that it was over unity. Brought that to the patent court, and regardless of what the results were, they decided not to give him a patent. So what's the reason for it? Is same old story: national security, disruptive technology. They wouldn't admit it, but he knew that's what they were talking about.
Got it.
It's all lobbied. It's all controlled by the oil boys. The worst thing to do with the over unity machine is get a patent. That's the worst thing you can do.
You're giving
it
away
release to the public. Is that the best thing to do, or what do you do instead?
Yep. Just open source it and give it to the world.
Free.
That's what free energy is. Give it away for free. And then
it's given. If you got it for free, charging for it is, to me, it's wrong. Don't get me wrong. If you want to charge for your time, I understand that.
That's different.
Yeah.
But not it itself, right?
Yeah.
Open source it. Even Robert Adams, okay? Perfect example. He built the first Adams motor back in 1967. He tried to get a patent in 1977. Then he was almost taken out 3 times. So he went into hiding for a while. Finally, in 1992, he came out with the motor and said, hell with it. It's going open source. I'm going to release it to the world. That's what he did.
It should be done. Yep.
That's amazing.
So,
go ahead.
Go ahead.
You were saying you try and get rid of parasitic capacitance, yeah? Is that what you were saying earlier?
Well, not parasitic capacitance, parasitic electrical fields in the power grid.
Right.
Now, in the coil in the Adams motor, what happens is a lot of times you get capacitive inductance. So you get all this power. When you got a huge massive coil, it acts like a capacitor. It stores energy.
Yep.
Right? So you need the means of getting it out. And the frequency that the piezo transducer it gets that potential high enough that it has to release, and that's when the collapse happens.
See, I like to use capacitance inductance in my system.
Sure.
It's actually kind of incorporated into the whole thing. So
right. So
different systems, though.
Yeah, like if you're trying to generate a field that you can, use it as propulsion or gravitational, that's different. But for a power system, you want to utilize that capacitive inductance in a positive means of getting it out, create that collapse.
And high frequency, very, very high frequency.
So mine, I did test on my motor on the scope, and I was registering about 127 hertz. That's on the output. But my hunch is the transducers are hitting about 300.
Scott, that's Real Genius. Scott DeBloy, just so you know. That's the other movie. Real Science, you're mixing up weird.
It's funny you bring that up. Like, I was with Amber, my basically wifey, and one of our mutual old friends last night, and Cody's like, Bernie, I swear to God, Amber is like the girl that's cooked up in Real Science or Weird. Oh, was it Real Science or Weird Science?
Real Science.
See, it's Weird Science and Real
Weird
Genius.
Science.
See, Real Science, we win. We took over the whole thing. It's amazing.
Indeed.
Wasn't that the one with Val Kilmer?
Real Genius is the one with Val Kilmer. That's the one with the popcorn. That was a great movie because it's about the lasers. It's about kids. Hold on, let me find it. Real Genius is about kids who go to a college, and there's a kid living in the dorm, in the closet, and then Val Kilmer comes, and this kid comes because Val Kilmer couldn't do it, and they're all just trying to build this freaking laser that they're like, hey, you hot shots that are so smart, build this laser for us. If you can do that, then we'll give you a little badge, a little medal that says you're good students. But what they don't know is it's all a plot by the U.S. government to make weapons. And so to get them back, they turn the weapon on the house of the professor and fill it with popcorn and make it pop popcorn. Turn it way down,
That's the way to do it.
Not a bad deal. Not a bad deal. Real Genius. Good movie. I recommend it.
It was.
But I'm sorry, I did not mean to disrupt Mike. I mean, from what we were talking about in terms of dielectricity and energy field stored up. The Newman's or the Adams motor. Let's go to that.
Yeah. So he decided to release it, and I never knew about this guy till about 4 or 5 months ago. Wow. And I saw his patent. And I'm looking at his motor, and I'm looking at my motor on my table. And I'm going, that's my motor. I just realized I built a motor exactly the way Adams did and never even know who he was.
Right.
So
it's just the right thing to do.
So the key feature of his system was a disruptive discharge. He was using a rotary switch. I'm using actually an automotive 12-volt relay switch that you can buy from your local Canadian Tire. And that is my spark gap switch. That's where I'm getting the disruptive discharge. I wanted to build a motor that anybody could go to the hardware store and auto parts store and put one of these together. It's not a matter of building the motor and making it work, and you need a crazy machine shop to make this stuff. I wanted to build a motor that I could show everybody that you can go to your local hardware store, buy the parts and make it. You don't need a fancy machine shop or, a laboratory to build this stuff. You can build it in your garage. And I think that's very important, to connect with people like that.
Is this a conspiracy with the hardware companies to sell more copper wire and magnets?
Yeah, look at the price of
says
copper.
Falcon Research Labs, right?
Well,
I'm just playing.
No, it's true. Look at the cost of copper wire now. It's crazy.
It's hard
to. The original conspiracy of the light bulb, where the original design, the light bulb never burnt out and lasted forever, and it's like we still get this garbage that constantly breaks down, erodes, is inefficient, is doing heat loss as well, where it's like, oh man, just everything should be the more advanced LEDs and so much more to it. It's just insane. It's ridiculous. And even the LED quality we get is garbage, where it should be like at pretty much zero usage of electricity with it, and like they last forever. Like how efficient the design and technology can be with it.
Yep, generators without moving parts is going to be part of the future, I believe.
Yeah, I worked on a device called the MRA device. Norman Wooten designed it. So I replicated his device, and it does work. Something that it's a solid state device, uses a piezo transducer, a small coil, a signal generator, the old type, like the old Hewlett Packard audio signal generators. You use that, and I replicated it, and it does work.
Nice.
So, that's definitely a good project to work on if people are interested in it. There's quite a bit of literature on it. His also was seized by the U.S. Patent Office.
Of course.
So, yeah, that was in 1994. It got seized. And
patented.
Well, yeah, exactly. So now he knows. He's in his 70s now. So I still talk with him every now and then. I chat with him in the EV Gray group board that we have. So if I have any technical questions, I know I always get a good answer from Norman.
Nice.
So just in that demonstration there, I was showing the difference between using the transducers and not. So without the transducers, I could only light one light bulb up. And each one of those little bulbs there, they're the neon bulbs, they take 90 volts each.
And I'm sorry, you said are there gases in the transducers? What are in the transducers again?
It's quartz crystal. It's
quartz crystals. Wow.
Yeah.
Do you use those to create your potential, or do you use those as pickup coils?
They're in parallel with the drive coil of the motor. So you just basically attach them together. I got 4 of them in parallel. Those are them right there. And now I was talking with Bernie about, I was talking with Bernie, I think, about it. If you hold on to those transducers, I'm starting to notice some health benefits. I find that it helps with arthritic pain, getting that little electrostatic discharge on your fingertips, noticing some changes in the body that are actually making me feel better, more alert, reduces joint pain and stuff like that. So,
and maybe not like medical advice, but at least in terms of cosmetology, the Korean electric face wands on Amazon and all these things that they sell you for your hair electric follicle stimulators and things. I mean, you can buy products that might not be as good as it, but it still tell you that they give you some of the benefits that, I mean, it's totally true what you're saying.
Yeah, because I kind of found that out by accident. I just started holding on to them, and it's like, this actually feels good in a weird way. You know what I mean? It was just like, I just wanted to hold on to it. I just wanted to feel the power. And
quartz does resonate with the body, so
yeah. And I've been doing it now. Every time I run the motor, I'll always put my fingers on the transducer.
Bernie, can you really quickly pull up my screen for just a second? Oh, it got taken. Let me open this image there. Can you see that there? This thing here. So I had this as a kid. My dad had this thing from like
wow.
From like
you had this as a kid.
Yeah.
God, and looks like
we still have the thing. Yeah, it's basically each one of these attachments are glass. Some of them have gases in them, I think, depending. And you attach them.
Yeah, those are all crazy plasma tubes. What, like?
Right. And I used to just rub my head. I used to rub my head with the thing as a kid. Just rub the back of my head.
No wonder you're so cool.
I feel like everyone should get these things, and you can get them now. I don't know if you can go to if you type in electric face wand. Is that going to be the word for it?
Those are like circa 1945.
Yeah, 1890s, 1940s. They've existed forever, but you can get them now. So is the point. You can still buy the thing, and I'm pretty sure Everyone needs them. I know that seems like a sex toy. It's not. Don't do it. That's probably going to hurt. Just put it on your head.
Yeah, I don't talk about the medical aspects of the coil system.
You know what? Ironically, if we sold it as a sex toy, no trouble on YouTube. That's the irony.
You're probably correct.
Guys,
Hey, can we do it and call it the Honey Boo?
do you find the Honeyboo free energy system arousing?
Yeah.
Mm,
Yeah.
oh God.
The honeyboo healer.
Oh boy.
Only if it spins.
Guaranteed to add luster
Or
to
vibrate.
hair follicles. Yes. Side effects may include free energy.
Yeah.
Amazing.
One of the
I-
side effects, that's all.
Like as far as the quartz crystal, the effects that I think they're contributing, like the Casimir effect, and Hutchison talks about that too. You know, the Casimir effect, and his crystal cells are vibrating and actually utilizing the Casimir effect.
Explain the Casimir effect a bit. I'm gonna try to Bernie. Let me pull up the screen. I'll show the picture of the Casimir effect.
So the closer you put two plates together, there's forces in between, and the ether is actually going to push, or the vacuum energy is going to actually suck those two plates together. So you got the two plates getting closer and closer, and we're talking within nanometers here.
Right.
We're talking like
20,000
really
angstroms. Yeah.
Yeah, you're getting real close, and when the forces of the ether on the outside of the plates is pushing that together, that's where the energy is. That's where the 0 point fluctuation, that's where it's happening. So
this is kind of that dielectricity that we're talking about earlier.
well, it's the ether. The ether has a force. You know, gravity is probably one of the weakest forces out there. Ether is around us, and because you're getting those plates so close together, you're at the nano level that the ether pushes them together. They join, and that's where you're getting that energy is from. That you're not putting any energy into it. This is the ether pushing it together. So that's a perfect example of 0 point energy, because there is no energy going into it to make it work. It's just happening. And they say it's impossible. Well, obviously not, because the Casimir effect is pretty well known in science. So
Yeah, well documented.
And a lot of people actually, like, especially the Tesla Tech videos, presentations, I'd say like half to at least a third of the people go into connecting the Casimir effect to some sort of 0 point over unity energy and
that's what it is.
usage.
Yeah,
It's interesting because they try to teach us in school, you know, because we see it in artifacts and making carbon nanotubes or different small substrates, that it has to do with electrostatic, and it's just kind of almost an electrochemical reaction to the electrostatic density of an object.
You're going way smaller than that. You're going down to the Planck scale.
Right.
Okay. You're going to basically the smallest of the small.
like angstroms.
I
So
think
It's all about the spark, right?
if we had like these cavities, right, you could put like a plate. Say I sprayed a little one atom layer thick of something, and then I put another surface sheen like chrome coating on top of that. You create these kind of like Casimir cavities on the surface of your craft, and then you pump the dielectric. You basically have a dielectric layer in between metal layers for a sandwich on the surface.
Yeah.
Of this craft. That's kind of what I actually want to do with my experiment here. I bought a 14-inch hi-hat cymbal that on sale because it was missing a pair. It was like a lone one out, so I bought it. But I was gonna start coating it with alternating layers of like chrome and dielectrics, and then trying to pump those cavities with. I'm either thinking of the vibration, you could create voltage through like a piezoelectric if you could like.
Well, yeah, I think that's what Hutchison is claiming, that, you know, the Casimir effect is why he's getting the power out of these crystals.
Hey, Bernie, can you do me a favor? I sent you an Instagram video. Can you play that on this thing?
I don't know if I have Instagram on my. Actually, yeah, man. Oh, it's on my freaking.
I don't know if I can send you
Google. They still, or YouTube. Still have
I
my
sent you the.
Bernard Tonkin channel banned, so it's like a.
I sent you the link in Facebook. So if you have it in
I'm
Facebook,
still locked on my freaking Facebook too. It's been a bloody month now.
well, I'll send it to your Gmail then.
Yes, I can do.
It's that good. Okay.
Why
Pantry raids.
did you put it in the private chat?
Because I can't get it from my phone to the.
Oh, gotcha. Yeah.
I guess I could log into my Instagram. Anyway, here's the point. There's so Biggs just said, build me an arc rectifier, and so this is that picture of an arc rectifier.
Goes very deep into these plasma arc rectifiers, and they're supposedly the most efficient AC to DC transformers. They were used like in the late 1800s, and
that's one sexy Egyptian light bulb, right? Like, so the
Dundera light bulb.
The video I sent you is from Lady Tartaria, Camel's friend in Australia, and but she's posted it from somebody else who's gotten an 1890s elevator and shown the mercury arc rectifier in the elevator still being used 120 years later.
Right? Like, it's just crazy.
Yeah, that's mercury.
We had a number of people in the chat that are leaving, but I wanted to point out the alien scientist at gmail.com. We're in New Jersey right now, having like a weekend here at the lab. And if anyone wanted to come get in contact with Mark or myself, if they want to come down and do experiments or just or whatever. So yeah,
right. Make sure you guys go to Alien Scientist on Twitter and subscribe to him, as well as on the YouTube for Alien Scientist. And you can also visit altpropulsion.com. But through Alien Scientist on Twitter, you can reach out directly.
Yeah, and I posted the links for Alien Scientist channel in the live chat. Well, everybody's channels, so that's on screen. I've been posting their channel links in the live chat. Once again, I'm doing Falcon Space, and then I'll do Jeremy's Alien Scientist again for you guys, and live tomorrow for APEC 2-year anniversary stream conference.
Yeah, and we're going to be here live at the lab down in New Jersey.
It's pretty epic team together there right now. But if you guys are about to log off, you better bring everybody together to do a team sign off.
Well, I'm getting tired here, so it's like 1 a.m. So I'm gonna get everyone to come in and we'll say goodbye before we log off. All right, cool. Let me go round up the troops.
All right. In the meantime, then, Charlie, take care of the dog. Speaking of dogs, I was earlier when you saw my face down. It was I was talking to Nancy Hutchinson, and she was talking about her and John and their next appearance, and that they couldn't make it tonight because they were a bit tired, as they just got a new puppy, and the puppy has been messing with their sleeping patterns. But they will be joining us again, hopefully next week, for more on the development of the crystal battery.
Hey,
very cool.
I met John a long time ago, when he lived in New Westminster.
Right now.
I actually lent him my truck so that he could move out of his apartment.
Well, that's always
nice.
Long time ago, through a mutual friend. We used to know each other. He used to actually drive a boat as well.
World, right?
That's a interesting thing. Ex-minesweeper used to float down the Fraser River. So I think my next experiment, I'm going to show kinetic inductance. You guys know what that is? Kinetic movement without having any magnetics in the coil whatsoever.
Wow, no. Tell us
Yeah,
more.
it's you know what? I could give you the breakdown. It's a manifestation of the inertial mass mobile charge carriers in a alternative electric fields as an equivalent series inductance. The kinetic inductance observed in high carrier mobility conductors. Basically, it's like a superconductor, right? I'm going to
Here,
show you
tell me the name. It's kinetic inductor.
kinetic inductance.
Inductance. You keep talking. I just want to pull up some pictures while you do.
Yeah, so the idea is to demonstrate that on my next experiment and put it on video for everybody to see. Basically, I'm going to be able to spin a magnet and flip it around, but yet my coil won't be magnetic.
Wow, interesting. Looking at the picture of some of the successful designs of a kinetic induction system. Kind of looks like the Greco sun symbol or something like that.
Kind of. It looks definitely like it's a spiral of some way, shape, or form.
Yeah, fair. Kind of ancient. Yep. I like it.
Indeed, right?
It actually reminds me of the hydrogen cell that I've made and have as a design. It's a flat stainless steel wire in a spiral form, but it's one way, one the other. And man, does it ever make a lot of hydrogen. I was blowing it up like it was going out of style. It was awesome. I'll demonstrate that in the future.
That is epic. So, I mean, how does it work without the magnet? Just the field, or
it's just the fields? It's the AC interacting fields between the primary and the secondary coil itself. Epic. It actually creates spin, which is very interesting. Yeah, I use different instabilities. I don't know if you'd actually classify them as instabilities. I use different types of situations to make this work, like diachotron instability, the proximity effect, parasitic capacitance, the skin effect, fractal design. All those things are incorporated into the coil in order for it to work. If one of them wasn't in there, the system itself wouldn't work the way I've demonstrated it to a few people, actually. And soon everybody will have one in their hands and they can play with it.
Yeah, I mean, the more you see some of these jewelry people that are doing these things, they're wrapping crystals in these energy things, and the more it makes me think. I mean, a lot of them know it too. They're like, "Yep, this is something. We don't know exactly how it works, but it's connected to something that clearly it has an effect."
Yep, definitely does. The rodent coil. Yep. I've made a few of those.
Here, you can go back to that. Where was that? Did I just have Bernie? Did you have that?
I'm curious as to whether or not Bernie or
on the internet. Just like I could really use some help out there.
Come say goodbye. Hey, can we?
Oh. Yep.
All right, Mark's being a fucking dickhead, so whatever.
Oh wow! All right then.
And he's just fucking acting up, dude. Like he's just like he came in here and like I told him to come in here.
All right. Let's meet guys.
Down.
Bernie. Yeah.
Cut
Bernie. I don't want to do them.
People are tired. Is Charlie there?
Yeah. We keep it clean. Trying to keep it clean on the show. But thank you, Jeremy. Thanks for the lab, and we'll see you soon.
Absolutely. We'll see you tomorrow for APEC. Yeah, I guess there's a lot of science going on there.
Science happens, guys. People have to understand how crazy it is to work in a lab, and it's really loud all the time. And people are there all day long and stuff like that.
Indeed, a lot of pressure, a lot of different people there, all all getting ready, trying to get everything together. A lot of responsibilities for presentations for APEC tomorrow. I'll actually be making my APEC stream for tomorrow as soon as this is done, setting it up. So we will be live. It'll also be live on Alien Scientist channel.
APEC is good. I'm glad
Xirtus, do you want APEC to run on your channel? I can make it run on your channel tomorrow if you want.
APEC. How long is it going for?
6 hours usually.
I might be into that. Yeah, okay. We can put APEC
Brother's got a presentation. I've got a
let's
presentation.
do APEC.
Gerald,
Let's
are
do
you
APEC.
gonna do a presentation tomorrow, or do you mind if I play some of your pre-recording of what you are going to be doing at APEC as a teaser?
You can play it if you wish. Yep. I was not scheduled to go on APEC. I didn't ask because I wasn't. I didn't put a presentation together. I've been working on some other things, so I don't know if you've seen the last video. I was able to light a bunch of stuff at 0.01 watt, so that was fun.
What up? We got Jeremiah.
Jeremiah, you show up now? Oh, hey,
Jeremiah. What up, brother?
Where are you?
Do we get the plasma wands? Please tell me we're getting the wands.
The wizard wand. You probably put on pants.
Yeah. Okay, we'll get to it. I'm just jumping on for a bit because I have a whole bunch of coils to wind, 20 in total. So
that's fair.
Wow.
So, anyways, yeah, we'll just kind of go over this real quick. So here,
solo it up, Bernie. Come on, let's see this.
Let's see. Better flip that. There we go. That's better. Okay, so I just have a piece of dielectric over a piece of foil here, and
nothing too fancy, right?
Since we're talking about plasma and wands are definitely something that I think belong together, and you certainly aren't going to get that kind of a thing from a piece of wood. But,
so you guys saw plasma wands in the title. You thought we were kidding. No, here they are. Here it comes.
Jeremiah never lets down. JP.
I let down all the time. But
magical.
Well, don't jump yet.
Electric power. Okay, so what I'm going to do is this thing can generate a holy crap load of voltage, and we can kind of see if I just bring this kind of close here, like we can see that there's some corona, some plasma.
Wow. Okay.
Okay, but I'll tell you what, because I got quite a bit of light going on here, so just hold that on. Let me turn down the lights because it just looks so much better when you can actually see the effluvia.
Everybody is in for a treat and a world debut, unless you've published it already on your channel. But
I don't know. I showed okay, so here's another view of that plasma.
EVO's all over.
Oh, look at that!
But you see, this is the thing. This is continuous, and this is what happens when we actually let that charge build up. See, now instead of allowing it to discharge to the foil underneath, I'm going to let it charge up the surface of the dielectric, and we get a very different effect where the energy is now, instead of continuously flowing, stored up and released.
Oh,
yeah.
That's beautiful.
Every day I'm slithering. That's pretty good.
Okay, so now that is...
This is like puts Harry Potter kids on a whole new level. Like, don't mess with the Harry Potter kids anymore.
Well, I mean, yeah, this it can levitate a feather, and all that good Wingardium Leviosa stuff.
You mean it can levitate a feather? Tell me about that. With electrostatics?
It can levitate. It's 130,000 volts, so you can definitely levitate a feather. All you got to do is, well, the way I usually set it up is I place the feather against my hand, in my left hand, and I use the wand in my right hand to throw ions into the air and let them stick to the surface of the feather. They want to get to my hand because I'm the other electrode, and as you can see, I'm holding this handle here on the other electrode. Now, technically, right now, I'm using a magnet to hold that alligator clip down to the bottom of the ground plate, because otherwise, as soon as I touch this to the surface, it'll give me one spark, charge it up, and then we won't get anything else. So I need that ground electrode to continuously drain this thing. Otherwise, we won't get that.
I wouldn't want that.
That's the general idea. And then I'll just charge it to 130,000 volts, and my hair will stand up, but nobody will see it. So. Anyways, what you do is you charge the feather and get a bunch of ions stuck to it. You'll peel it off your hand; it'll want to stick, and then you'll see all the little tendrils of the feather spread out, and it's charged. So at that point, you just toss it up in the air, give it a throw, and then put the wand underneath it and fly it around the room and do whatever you want with it.
Wow.
So I'm going to kill that video for a minute, and then I'm going to switch over the other experiment, which is the one that I was showing you the other day, Bernie. Whoa, yeah, that still has got quite a bit of charge. Yeah, 130,000 volts will hold on for a while. Actually, that if I take that same piece of plastic that you just seen, it's about, I want to say 8 inches by 8 inches. Anyways, if I stick that thing to a door, and I have a set of strings, if I attach it to something more rigid so I can pull on the whole entire surface without causing it to bend, it will hold itself to the door with over 1 pound of force.
Wow. That's pretty good.
It's just, if you think about it, the amount of force that something has with an electrostatic lift or any kind of physical kinetic force exerted onto it, well, that's entirely something dependent on how many charges have been thrown off or separated from each other. So if you have a very, very large number of charges distributed to a very close proximity to an opposite number of charges where they would like to get to, and you have a thin dielectric, in my case, that dielectric is pretty darn thin, and it can withstand, well, as we just seen, it takes 130,000 volts. So because of that, you're talking 130,000 volts in 0.08 millimeters of space. That's a few trillion charges, and that's why you get 1 pound of force.
Wow.
All right, so I'm setting up the other one, and I'm just about there.
Now that's science.
Well, that's also fun.
There's so many questions
that's the
now
good
about the field.
What they call fancy science. Okay, here we go. Flip this again. Oh, I need to turn that on.
Crystal Clock Energy Field will be the name of my new album.
All right, so I've just got it on battery simulation, 8.4 volts, which is 2 lithium-ion batteries. It's the same thing that runs the other wand. There's the driver circuit, which I'll flip the lights on and show you later on. But basically, this is the other wand, version 2.4, which I never finished. And it can crank out quite a bit of power. This one is over 160,000 volts. And in this case, I've got this really nifty little feature where I've got kind of a variable pressure switch. So you just start to press it, and you can see it starts to draw just a little bit of power. But as you press it harder, you can bring that power up. So now I'm going to try a discharge to the surface of this totally screwed up neodymium magnet that I messed up pretty bad because I've been running these kinds of experiments with it. And we'll see if we can get it. Yeah, there we go. Yeah, let me flip that. See if I can flip this. My phone is probably going to freak out. It may lose focus.
Yeah, but see, when he says that it's not like Anderson Cooper, he means it.
Look at that.
Let me see if I can change the angle to get it a little more evenly distributed.
And like, watch the sparks, like the EVOs that come off. Like some of them move not how they should be. It's pretty crazy.
That's a pretty Evo. That one that whipped right around in a spiral form.
As soon as I said it, right? That it's like,
Yep.
man, it's like they're almost conscious. Like some of them, this ball.
I'll try to get the surface so you can kind of see what it's doing on the surface.
Sith fingertips.
Wow.
Julie, if you're just tuning in, and thank you for doing so, we're looking at, well, actually, maybe you want to explain.
We're looking at effluvia, and every so often the effluvia catches on to a charge cluster on the surface, and then the charge cluster eats a little chunk of the magnet and throws off a spark. So that's the fun thing that I was playing around with. And then what's really the main project for tonight, and the reason why I got to jump back off of here for is I have a holy crapload of coils to wind. Here are some. I've already finished.
The coil.
Got 2 more.
Look at that.
Here's a few more. I'm building something big.
Nice.
Yes, you are.
And
so
this entire platform is basically going to be, in simplest terms, a phased array.
That should be an interesting experiment.
It ought to be. It's going to have a whole entire grid arrangement of those coils. And then it's just a matter of really sweeping in tight on the waveforms that it needs to drive it. And, okay, so if you think about it, like, what's a bifilar coil do? Well, let's take a look at the difference between the two. This is a monofilar coil. Wire comes in from the center, wraps all the way around to the outside. The actual voltage, if let's say this coil here is 24 turns, and all these coils are 24 turns, so we can use that as a good reference. If I put 24 volts across this coil, the voltage between each of the turns will be 1 volt. This is another 24 turn coil, only this one has 2 wires that run parallel with each other, and the way it's wrapped is, this is an unfinished, so you can see the wrapping. 2 wires come in from the center, they go all the way around just like this one, they come back out the edge, and then what I do is, we can see this one's blue labeled, this one's blue labeled, these are the same turn, so I take the end of one turn connected to the center of the other, and now I have the same 2 input leads. Now, the same 24 turns, if I put 24 volts across this coil, the voltage between each turn is going to be 12 volts. Why? Well, because halfway into this coil with 24 volts across it is 12 volts, and at halfway, the same voltage there goes all the way back to the outside. And so what ends up happening is there's a capacitance built up between these turns, the equivalent of a 12-volt capacitance, which doesn't exist and cannot exist with this type of coil. And so as the frequency on a bifilar goes up, what will happen is the magnetic field will change from being north on one face and south on the other, inverting back and forth like a normal coil, and it'll actually start to turn itself and phase shift and rotate the angle until the north and south dipole is now inverting between inside and edge and inside and edge. And when that happens at resonance, you basically lose any kind of magnetic field coming off the surface that a coil like this would pick up, and the signal seems to disappear in the Fresnel zone, and the Fresnel zone tightens up. So the idea is these things concentrate electromagnetic energy very, very tightly to the surface. And if you stack up a boatload of them in a phased array, where you sequentially fire these things, or you fire them at their own native frequency where there's a wave function built up, you get a superposition field, or just shortly called a super field. And that field can become so strong and so isolated from external fields that, we theorize at least, you can phase this system by, or you electromagnetically phase out of a coupling with the gravitational field and any kind of lens forces that you might expect. Since the lens force is here, you know, the fields basically shift 90 degrees so they can no longer couple.
That's beautiful.
It's a lot of coils. Still got a lot of winding to do, and I'll just sweep right over here, and I'll pop the lights back on for a second, and then I will show you how I am doing this without pulling my hair out.
No doubt, brother. No doubt.
Okay, so
thank you for taking the time off to join us and give these demonstrations, because my God,
that's a big old
mad respect. Mad respect.
This is a big old spool that that I dumpstered for many years ago when I was at Caltech. This digital equipment company that built medical monitoring gear was tossing this thing, what, like 40 or something pound spool of this beautiful multi-strand. It's never going to focus. Multi-strand silvered wire. It's like a 9-conductor copper, pure copper. And so, because I have so much of it, it's a perfect kind of thing to make a bunch of coils out. So to make them nice and even, I got a Lazy Susan from Home Depot. And this allows me to very easily just simply rotate these turns on. And then this carpet tape, it may look dirty now because I spawned a bunch of coils already and been around for a while, but it's still quite sticky. And then this is for the larger coil size that I'm now doing. So the tape holds it down while you're winding, and you can basically take your hands off except for the very end, and then you just do a couple of stripes of super glue, and bada bang, bada boom, bada bam, you got yourself a very easy bifilar coil that you can make in about 10 minutes. And they all look exactly the same. The wires end up at the exact same spot around the curves. So if you're really trying to get them to resonate with each other, as long as the wires are exactly the same length, they have the same amount of copper mass and silver mass, and so you can achieve that dynamic resonance of the nuclei, the spin nuclei magnetic moment, which is really the goal here.
Very nice.
I hope all that wasn't like all too much. But yeah, that's the basic idea.
I know what you're doing.
Excellent, brother.
We still got questions. Everybody go ahead and ask your questions. The more educated questions first. Mike and
Yeah,
Jared.
you're gonna have to just read them off.
Questions in all
Steve. Not
caps.
looking at the chat or anything. So if somebody's got a question and you see it, then you got to ask me now because I've got to get back to the winding of coils.
Fair enough.
I have a question about your magnet. When you were doing your experiment with the wand and your spark gap, the magnet itself, does it have any damage to it whatsoever, or does it?
Oh, it's been just getting worse and worse as I run the kind of experiments like we were showing today longer. It is thoroughly eating away at the surface. Yeah, it was maybe just ozone at first that was causing some kind of oxidization damage to the metals, but those things are nickel zinc plated. So anyways, over the course of years, I've been doing stuff with that magnet. So yeah, it's pretty well beat up at this point, but it's just eroded away, getting hit with way too many ions. I've never gotten it too hot. I've been careful not to cause it to lose its magnetic flux, but otherwise, yeah, it's pretty much destroyed surface wise. It's lost almost all of its coating. So yeah, that is hitting the raw and highly flammable neodymium mixture underneath, and it is busting little pieces of it off with that high voltage.
Very nice. You should do that experiment inside of a box and collect everything you can.
I took some slow-mo of it, which looks super cool. I actually noticed in the slow-mo you get these little particles flying off, the blazing particles as they're flashing, like curve around the magnet, and you can see them curve in the field. And I also noticed in the slow-mo video that the plasma coming off of the tip of the wand is spiraling pretty heavily in the field in front of the magnet, which looks super cool. But you can't really see it, at the low frame rate. But yeah, in slow-mo, you can actually see it move from the tip from left to right towards this thing, and it has a very definite direction. Looks like watching a trace on an oscilloscope that's out of sync. So I don't know. It's
awesome experiment,
stuff,
brother.
man.
Awesome.
It's nice to see torsion in action, right? To actually see that field twist. And yeah, in plasma, we already know it's basic basic right hand rule, Lorentz force. But you can do a lot with that on the very fine scale that starts to act a lot not like Lorentz force, because the Lorentz transform is stressed due to the high energy in that space-time. So, and you start to get something that shifts so freaking far out, and because it's oscillating, it doesn't keep its same angle of coupling, you could say, from one reference frame to the other. You get a shift in the coupling coefficients that oscillate back and forth. So just depends when you're sending energy out and when you're pulling it back in. And if you can get them phased nicely, you can set up a real cool oscillator for that volume of space-time.
Yeah, does it matter if if your mass is a little off on one side, maybe you have a little bit too much coil bundled in a certain area, it's not perfectly symmetrical or something?
It matters, and if it's off, then you're going to have to trim that thing until it's perfect, or damn near perfect. I mean, there is a very tiny amount of tolerance, and it all depends on how you set it up. Like, for example, if you wanted to run a higher current system and you actually had to match capacitors with each of these coils, you would want to leave some extra lead wire and sort of tap it along its length in order to tune it with those capacitors, because their values are going to be slightly imperfect, you could say. None of them have like a perfect 0% change. They're usually 5% or 10% value. So all that stuff has got to be accounted for. I'm not running capacitors in the platform. I'm just going to be running that pretty much signal direct. So
very nice.
Mike, did you have any questions on this?
No, I don't. I'm drawing a blank. It's getting late here.
Yeah, no worries. I mean, we're pretty close to the end here. We'll do. Is there anything else you guys want to cover before we start to tell people where they get more of your content?
I'm still slowly posting stuff up on the Exotic Repulsion channel, and I'm pretty much not posting anything on the Join the Technicians channel just because I don't feel like finishing the edits on the videos. I have a bunch of them that I just never posted, and probably would take me a good 20 hours or so to finish them up, but I'm really quite busy right now and don't have the time for it.
Have you done any more experiments with the carbon graphite magnesium battery?
No, I haven't really played with that at all. I've been seeing some development work from other people.
Some of those batteries in with the crystal batteries and see if you can combine the effects of the carbon magnesium style ones you've got in a core somehow in the crystal battery style, and see what sort of crazy effects we get.
I'm considering,
And
when dealing with power
monotone.
gains, right? I want something that's repeatable, something that can continuously give me a sustainable output, or something that's I don't really have to do a lot of assembly work for. And I like the idea of filling liquids that are reactants into certain things. So I was playing around with that thermal reactor, the helium to arc converter, and I finally got new temperature gauges in. That took a little while, and did a basic test from 100 degrees to 150 degrees Fahrenheit, and I was able to reach basically that amount of time in approximately 15 seconds. And within about 30 seconds, the water was boiling and steaming off. And so here's the thing: the circuit that I powered that with is only capable of delivering about 15 amps, but you can already hear the wires, about 12 amps. It's already stressed. So it's just not designed to deliver that much power, and it's 120 volt American power. So those two things being said, if you calculate the 100 milliliters of liquid of water that I had inside there, it seems that I was able to heat 100 milliliters of liquid from 100 degrees to boiling point in the amount of time it should have taken me 2,700 watts to do. And I'm doing that with about 15 amps at 120 volts, which is quite a bit lower. So there could be, I know that there's a reaction going on. I mean, that's for sure. It's eating the tungsten, and that's not exactly an easy feat to do. You can leave tungsten in potassium hydroxide all day long for years, and it's never going to go. But this system is eating it pretty quickly. So I know that there's energy coming from the metal, and that's probably where the extra thermal power is coming from. But nevertheless, converting a metal and using that as a fuel, I think, is equally interesting, because you don't hear a whole lot of that. And so, I don't know, I think there's something to look into with it. It's not where I'm going to focus my efforts, but just knowing how the effects sort of take place and seeing that, yeah, you can actually get thermal gains. And as far as I'm theorizing, the place where they're coming from is actually from the metals themselves, being down converted, ripped apart. I'm not sure exactly what's going on. I haven't tested the sample water to see if I have other elements in there, although Bob Green here would probably be screaming at me to make sure that I do. But anyways, yeah, it's not my focus, but it is something that I think is worth note, because if we can convert other metals that are cheaper than tungsten or more obtainable than tungsten easily and get extra thermal energy, it's a heck of an alternative to burning coal.
This requires magnets, and do we have to recharge these magnets?
It does not require any magnets. It does require water.
Okay.
And it does require some kind of electrolyte in the current way that I'm doing it. In a pressurized chamber, you would actually go with pure water. But
Interesting. Well, this stuff's amazing, guys. I appreciate the time that you took. I think we should do this again next week. Anybody who wants to bring more stuff, Mike, I'd love to also look more into your solution, because it's coming right back to what you worked on, sounds like years ago, and you've got a new solution for her, so that's amazing. And Gerald, yeah, I can't wait to see more of your stuff. Can you also, Bernie, type in Gerald's new YouTube and pull it up so everyone can subscribe to Gerald's new YouTube channel? Gerald's channel got hacked, so now he has a new channel. It's almost back up to what he was at before, but let's try to push it over to the edge. Let's give him like 1,000 subscribers and get him going on his promoted new channel. Locked in.
And next week we'll have some more experiments for you live.
Epic. That's awesome.
yeah, that sounds pretty darn good to me.
It is WP Gen Lighten for Truth 2. And the link in the description below, if you're looking for it, it is in the YouTube. You can find it and subscribe. Click on the bell. Make sure that you get subscribed to his experiments so you can see the work he's doing.
Yes, please do. There's
Yeah,
a whole
Goblin's
bunch
had
of
a
stuff
couple
coming out.
questions there too, Xirtus.
Oh, here's a question. Is there a way to measure the Earth's natural magnetic field to suss out the actual shape of our realm? Any thoughts from the engineers?
I wouldn't try to use the Earth's magnetic field as any kind of reference for a quote-unquote realm, but I guess if I were to interpret the word realm as the shape of the substructure of this universe, which in physics we could call what exists on the Planck scale, and why we have quantized finite units of individual space-time where it doesn't seem like anything happens between there. Nodes and antinodes, you look at the node of a guitar string and it doesn't look like it's moving, but obviously you get the entire vibration still. So a lot of people theorize that at the very tiniest scale of our universe exists this entire very complicated lattice of tetrahedral types of geometries and various different types of geometries for interconnected nodal points, wherein at these points basically matter can exist and it can't exist in the space between, so it just jumps from one to the other. And this is sort of the quantized universe view, and a lot of where quantum physics comes from, the idea that things can only happen in discrete packets of exacting value. So there's a lot of problems that I have with the conventional approach to our modern quantum physics, but just to kind of give you an idea, yes, it could be that space-time itself, the actual vacuum, does have a real shape, and we might be able to manipulate that shape using fields and forces in order to create something like warp drive with fairly low energy levels. Because instead of having to, say, brute force our way through macro fields, we might actually be able to create a sort of motion within a field that grabs onto that physical structure and sort of rolls us through it, almost as if you were rowing a boat through water. So I think a lot of where we're going is looking into trying to understand this physical nature of the
Same
universe.
amount of water, bigger waves. Right.
Right. And then this would be.
Wait, go back though, Bernie. 'Cause we need to show Mike Faraday's research page and tell people. I know we was up for Instagram, but guys, go to Mike's page, Faraday Energy Research and Development. The link is also in the description below. Make sure you're subscribed. He's doing amazing experiments. He's got designs. He's been doing this for years. It seems like over a decade at least of amazing stuff.
Yeah,
including...
and Mike, if you're there, come back quickly. And on his channel, there's the graphene battery build as well. Those emergency batteries, essentially, that anybody can do, and that we'll be doing more of the crystal batteries coming forward with the Hutchinsons. But yeah, Mike's work is truly next level. He's also got the water machine, where is it? Treating water with structured water with the frequency generators machine. Quite fascinating, and that apparently it's like 20% denser or something that we're trying to get tested and confirmed just from putting these frequencies into the water. All sorts of amazing different work if the stupid commercials would not play. Where is it? Oh, that's the second one he was building. He's got a couple of these guys now. I think this one was for a unit for.
I'm not sure which microphone has the praying mantis, but it's gonna be memed. I'm just saying.
All right. And oh, there's Mike. Mike's back.
Mike, what's up?
Good,
We're just checking out your channel.
Oh, okay.
Go there.
Putting you right on the spot.
If there's anything you wanted to say about your channel before we go, but next week, if you also are down, come back and we can go through some of your things like the restructured water, the graphene battery, some of the Faraday stuff. That'd be great to look into some of the work you've been doing for looks like well over a decade, and it's only more.
Yeah, the transducers, the MRA devices there. Yeah, I got a lot of stuff going on there. I'll be working on the HHO stuff probably in the new year. I'll be working on that again. I'm going to be trying the ultrasonics with the creating the plasmoid energy instead of actually producing the hydrogen.
Epic. Yeah, we can't wait to see some of this stuff, and I hope everyone in the audience checks this out. And in the description below, you can find the link, as well as here you can find at the top it says Faraday Research. What's it? Faraday Research
R&D,
Research and Development.
Yeah, so
very good.
A lot of stuff there for everybody. I got Don Smith stuff there. Norman Wooten stuff, my stuff, Gerard Morin, I rebuilt his device. So yeah, there's a lot of stuff in there to go through.
Right.
You kind of see the evolution of what I've been doing.
And Jeremiah, the technician's channel's in the link below. You guys can click on Jeremiah's as well, so you guys know how to find him. Also, he's not putting out as many videos as he should be, so we're going to drag him back here next week as well to make him show off where the progress has gotten him. Since he supposedly is wrapping these coils tonight, he should have something done.
Yeah, that should be an interesting experiment.
Well, it all really depends on the results, because I may decide after seeing something a little too crazy that I don't want to show what that progress is on it, but we'll see.
Hey,
Wisconsin is not nearly as far as you think,
open
bro.
source.
I'll find you.
Open sourcing portals for everyone.
Oh, I understand the open source, but sometimes showing things that are a little bit
That's true.
over the top gives you a little bit of that nervous crunch where you're not really sure if you should, right? But open source all the way, so it'll get out there. It's just a matter of when, I guess.
Join the technicians YouTube. Here it is right here. The
Yeah, again, I apologize because that channel has some really cool videos on it, but unfortunately, I haven't posted there in a long time, and I probably won't be focusing my efforts on more of, I guess, the general public videos, which is kind of what that channel is. It's a little bit more general videos, and now I'm really focusing more on the propulsion aspects and energy aspects of things on the exotic propulsion channel.
We want to
Very good. Well, you're talking tomorrow at the APEC thing, right? Or what?
Nope, I will not be there. I'm going to be having my hands quite full with other matters.
All right.
Unfortunately. So I do have one of those real sweet Hutchinson style massive xenon arc lamp tubes. This thing is good for 8 kilowatts.
Here, show his arc lamp tube, Bernie.
Let's see. Let me find the rest of that gadget to grab that. There we go. And take back the tip.
It went black. I can't see the screen.
Yep, I know. It's not you. That's
shame on you, Jeremiah. Shame
I
on
have
you.
to set my phone down to pick up the wand.
Eased us in like we're at the end of the show here. Come on. All right, there it is. Oh. Okay.
Very nice.
It was worth it. I see. All right, you are forgiven.
Very nice. I like.
It's pretty crazy that all that's coming out of the wand, hey. So what I'll see if
that was just from the wand. Wow.
Oh yeah, that's all. Dude, this thing is stupid powerful. It's stupid powerful.
That's awesome.
And that's the other power. I'll show you. That's the power supply from the new one with its variable push switch. You see the two heat sinks on the bottom, and it's got that custom 4,000 rep transformer that delivers the 8 kilovolts at up to. You can peak about 300 watts with it, but it doesn't like to handle much over 40 continuous. But
wow.
I mean, considering how freaking small it is, a transformer that size handling 40 watts already is.
Yeah.
That's asking a lot out of it, and all the electronics are on that board. So that's the variable. You can see it's kind of like a resistive push sensor pad.
Jeez.
And anyways, let me grab a magnet real quick. I gotta set the phone back down again to grab one.
You went dark again.
Yeah, I'm just gonna
put
these things next to it. Hopefully, we can get some cool plasma effects because I gotta stick this magnet. I never actually tried this with the tube. Never tried this exact thing, but hoping that I can kind of get it to curl a little bit or do something kind of interesting. Let me see if I can get this to balance there. There we go. Maybe that'll work. Oh yeah, check that out. Yeah, see now how it's kind of spiraling.
Yep. Interesting.
And I wish I could kind of leave my hand sitting there.
Yeah,
but...
spark gap quenching.
And so depending on exactly which direction the field is facing, it's going to do something entirely different. And this is part of that nice plasma control. So yeah, Tesla's favorite spark gap was a magnetically quenched spark gap. And you can see the reason for why. Because you can really use a magnet to control exactly where a plasma goes, how far it goes, and how many times it twists around. And if you can get that plasma to twist around a whole bunch of times, when it does disconnect and snap, not only is it snapping with the disconnect of the electrical energy that was passing through the switch, but it's also giving back the kinetic momentum that was stored up as it was circulating around, which gives a heck of a snap at the end. I mean, that's where his huge impulses were coming from, using magnetically quenched spark gaps. And he knew how to make a pretty strong magnetic field, so people think, well, today's neodymiums would just completely overcome what Tesla was working with. Don't think so. He knew how to make a strong field using iron and good old copper wire. Stronger than those. Stronger than Neos. not by size or not by size or weight, but absolutely by field strength.
Man, this is epic. They're asking if you have schematics for the wand available.
I do have schematics for the version of the wand with the black front head and the copper handle. So yeah, there are schematics I actually show in the video of how to make a real working electric magic wand. It's the one that Electro Boom based his magic wand off of when he did his 4K subscribers, like self-reward of building himself a magic wand after I turned down building one for him.
Very good. Well, guys, you heard it here. You know where you can get your wand schematics, and you can start working on this. Thank you, Gerald, Mike, and Jeremiah for joining us. Bernie for putting this on. We'll see you tomorrow for the APEC thing, and then next week, I hope you're there. We'll do this again. And by then, we'll have fixed whose ever audio problem that is, or they'll probably not be alive.
Jeremiah from the phone, or
no, it's Jeremiah. I would only talk this way to Jeremiah. I'm sorry. I love you, Jeremiah. All right, guys, we'll see you next week. Bernie, cue the exit. Oh yeah.
Next week we're gonna be doing deep cream of tartar. Oh my god! I got Nancy if you're watching.
Being glitched. It's getting glitched, man.
Rochelle salts, the saltpeter, and the sugar calcium carbonate to make the saltwater taffy crystal battery power cells. And I'll be doing a stream midweek going over all this specific supply list to be making it, and we'll also go deeper into other people's builds like this one. It's
saltwater crystal taffy batteries.
And, then he had like a bunch of things of it for 4 years. Can you buy me a better internet? Absolutely.
I think you need an Ethernet cable.
Absolutely.
You need a better Ethernet cable.
Please do buy me a better. On that note,
get him an Ethernet cable so he's plugged into a wire.
Well, I'm on Wi-Fi. I need to connect to my
Internet get a real wire. But yeah, we'll get everybody hooked up and set up. The thing is, they're more obsessed with science than they are with podcasting. That's why it's like we're all gonna get tight. Great. Yeah.
Science.
All right. Thank you very much, guys. We'll see you next week. Oh, Bernie, yeah.
One love. Tomorrow for APEC. And Mike, Gerald, Jeremiah, Andreas, love you all. Thank you for being here. We'll see you tomorrow for the APEC. And y'all, we're fire. Good night.
It was great.
Everybody.